Hello, my name is Chris Kobus. I am the Director of Outreach, Recruitment, and Retention here at the School of Engineering and Computer Science, and I am making this presentation on behalf of our Dean, Lou Chamra. The picture that you are seeing in this first slide is our Engineering Center, which we had moved into in 2014, and it's a state-of-the-art building that was designed purely for education. There are no research labs in here, there are educational labs. So who are we? Well, let me show you a video that will explain some of that.
Oakland University students form meaningful relationships with dedicated and engaged faculty who provide the connections students need to take their learning to the next level. OU's School of Engineering and Computer Science offers instruction leading to degrees at the bachelor's, master's, and doctoral levels. The programs are offered through 4 departments: Computer Science and Engineering, Electrical and Computer Engineering, Industrial and Systems Engineering, and Mechanical Engineering. The School of Engineering and Computer Science features an outstanding faculty dedicated to preparing learners for the 21st century workplace and society, as well as for research in their fields of specialization. The school offers close student-faculty interaction, small classes, and individualized attention. The goal of the School of Engineering and Computer Science is to provide students, faculty, and staff with the best educational and working experience in a highly supportive yet stimulating environment. Oakland is a rare public university that encourages undergraduate research as early as the freshman year. Students can conduct hands-on multidisciplinary research with professors who are published experts in their fields. Engineering and computer science faculty provide the highest quality of education, which is enhanced by cutting-edge research sponsored by federal agencies and industrial partners. On campus, the home of the School of Engineering and Computer Science is the 127,000 square foot Engineering Center, which features state-of-the-art classrooms and research spaces and a courtyard for student organizations.
So just a little bit about us in video format there. So this building and our faculty, we are committed to serving the students. That's why we designed the building as such. All educational spaces, student spaces, studying areas. We have our own tutoring center on the 2nd floor there. Our research focus is on applied research, and as such, we have many relationships with local industry, although we are also funded by the federal government, National Science Foundation, Department of Energy, and others. It's unique, though, that we have an opportunity for undergraduate students to come in and participate in research. And a lot of the faculty, myself included, have had many undergraduate students over the years that have participated in this. It is quite a rare and unique opportunity, but with our focus on applied research, this is research where undergrad students are at a level where they can actually substantively participate. We have 5 departments. Some of them are more conventional: mechanical engineering, electrical and computer engineering, computer science and engineering, industrial and systems engineering, and our newest department is bioengineering. And that department, the bioengineering department, we had the graduation of our founding class in 2020, and in 2021 we had an ABED visit, and after the ABED visit, once the accreditation occurs after that, then it will be a fully accredited department, just like the other 4. So in the electrical and computer engineering department, we have quite a few project and activities going on here on campus. You can see in the one picture the car on a rotating platform. This is to measure signal strength, for instance, from a satellite. And this car rotates around, and this big arm comes out of the ground, and it goes all the way around too. So we're getting a full hemisphere of signal strength, looking at antenna designs and that sort of thing. We also have an aerial robotics club, aerial vehicles, that basically they make their own drones. And they've been doing this for quite a few years before anybody knew that such a thing as a drone was even possible. In the computer science and engineering department, we're talking primarily coding, software development, gamification, and other aspects. Industrial and systems engineering is very different because this is one engineering discipline where you're not actually focusing on designing parts. You're looking at designing processes. So you're looking at human-machine interaction. You're looking at systems level kind of approach. So for instance, in a hospital, you have patients, doctors, nurses, you have staff, you have information, and everything, every component of that system has to flow together and work correctly. And that's the kind of processes that industrial and systems engineers look at. Mechanical engineering is very conventional, so there's two aspects to it. A lot of people don't know. One is the solid mechanics, and that's what most people think of when they think of mechanical engineering. It's parts, it's structures, it's gears, it's moving parts, and that sort of thing. But there's also another part to it that's the fluid thermal sciences, where we basically study energy. So anything that's related to energy conversion, alternative energy, heat transfer, any kind of engine technology, electrical systems, that's also all part of mechanical engineering. In addition to the 5 departments, we also have some engineering science programs. For instance, engineering chemistry. This is not the same as a full-blown chemical engineering department. We have engineering physics. It's a mixture of engineering and physics. And those are programs that some people find of interest. We have quite a few success stories involving our research endeavors, which again is mostly applied research, and not just getting students involved, undergraduate students especially, but awards, competitions, large grants from industry and from the state and federal government. So for instance, in the autonomous vehicle space, in 2016, we won a competition out of more than 1,000 entries in building a drone that has underwater as well as surface capabilities. And you can see where this would be quite relevant in the real world. If there is a hazardous situation out in rough seas, instead of sending people out, you can send a drone out that would fly out, go underwater, inspect damage without risking people. So our own Professor Osama Rawashday led this team of students to design what is called the Looncopter, and it did come with a nice $1 million prize. And again, there were more than 1,000 entries into this competition from 165 different countries, and we came out on top. So that's quite a success story for us. And all of our senior design projects, so in our curriculum, all engineering students have to participate in design projects before they graduate. And senior design is one of them. We also have some sophomore design experiences. But once they get to senior design, 100% of our design projects are externally funded, mostly from local industry, from inventors, researchers in the area. So our students get some real-world experience with these projects, and many of them end up working for these companies that they interact with for the semester in the design project. Our research focus areas, these are the different pillars that we have. Anything from smart grids and clean energy to cybersecurity, which is very important. I don't think there's a week that goes by without some big corporation getting hacked. Materials forming, fastening and joining, to applied electromagnetics and control theory, that's more on the electrical side, all the way to bioengineering, bioinformatics, tissue engineering, and that sort of thing. Recently, we have launched an augmented reality center that's industry sponsored, and you can see some of our industry partners over here in the startup for this center. So I think most people know what virtual reality is. You put on Oculus or some competing product out there, and you are basically seeing a virtual world. Augmented reality is a little different. You're still seeing the real world, but it's augmented with some virtual components to it. We have very recently also started Industry University Cooperative Research Center for Composite and Hybrid Materials Interfacing. And again, this is one of those 5 research pillars from the prior slide. And our own Professor Nassar is the site director for that, funded by the Department of Defense and others. This slide shows some research collaborations for R&D. These are some of some 100 companies and government agencies that we work with in developing products, processes, and doing some fundamental research. Very important here is that we have a very high job placement record. That means our graduates, they have jobs. Most of them these days already work before they graduate, the job coming as part of a summer internship or as a senior design participation experience. After graduation, our employment rate is in the 90% plus range, but that doesn't mean that 8% are unemployed. Many students just decide to go on to graduate school right away. So median starting salary is about $70,000, which is already one heck of a standard of living over there. As you can see, 85% have internships, and that's where a lot of our students find their first jobs. And one of the interesting aspects of our numbers are, and I'm not sure that any other university in Michigan can claim the same, is that 99% of our employed graduates are right here in Michigan, most of them in the local area. As far as program recognition goes, this is from the best graduate schools from grad reports. And you can see here that Oakland University made number 3 on this list, which is pretty spectacular, being that we're compared with institutions like MIT and Stanford and Ohio State. So you can see here this list compares salaries. Median salaries, and again, these are not starting salaries, they're median salaries, and our graduates are very competitive with some of these giant schools that have been around for a very long time. Here's another one, and this one looks at things like median debt, annual tuition, and again, we are very competitive with some of these much larger schools out there. And this one is actually pretty striking. If you look at a list of all these schools as far as annual tuition goes, you can see that as far as annual tuition goes, compared to some of these other big schools, we're very reasonable compared to some of these other yearly costs. We have a large number of student organizations, and these are just the ones that are most related to engineering. We have other university-wide ones, but these are active organizations that if you have an interest in, for instance, building race cars, you can join Society of Automotive Engineers and do exactly that. We have the Tau Beta Pi Honor Society. We have SWE, which is the Society of Women Engineers. We have the National Society of Black Engineers. We have IEEE for electrical engineers. We have a makers club. We have robotics. We have many different activities that you can plug into. And again, our Society of Automotive Engineers Club, this is something that any engineer can come to, regardless of whether mechanical or electrical. Building a car is very multidisciplinary as it is. And there are no requirements, so we have many times first semester freshmen that show up to the SAE garage and just basically state a desire to help build a car, and they're in, and that's it. Very active. The SAE students are on campus. They have their own garage space, and there are students here pretty much every day all semester long. Building the car is one thing. Getting to drive it on a racetrack and be judged on things like design, that you met the standards, in addition to actual racing, it's pretty cool. For freshmen and sophomores, we have a lunch and lecture series. So these are industry professionals out there, vice presidents and that sort of thing, that basically come to campus. We usually run one or two of these each month, basically telling students this is what to expect out there. Pay attention to your studies, pay attention to soft skills. This was my experience when I went through Oakland University, and here's how it translated to the real world. So they're not, these lectures are not meant to just do a deep dive into certain technologies, although some do to a varying degree, but just to translate the college experience to what ends up happening in the real world. So this gives freshman and sophomore students that may not know, they're still a couple of years away from being out there, what to expect and what to look forward to. We have other programs that students can plug into. So one of these is called ClickForm, which is the Chrysler Learning and Innovation Center. And every year, this ClickForm takes in a cohort of students that work in partnership with Stellantis now in terms of metal forming. So these are students that would be interested in working in a stamping plant and designing the next generation of metal forming technology in the automotive industry. And we have other programs like this that students can plug into. And along with this program comes internships for 2 summers and some relationship with the company over the course of the academic year. So it just gives these students in the cohorts a leg up really on the competition, because once they graduate, they can hit the ground running. They've already been through a lot of this. Another one that students may be interested in is called the PREP program. That's the Powertrain Readiness Engineering program, also through Stellantis. And here you're basically learning about powertrains, and not just internal combustion engines, but hybrid electric vehicles. We have hackathons pretty much every semester, and these are some challenges for students that are interested in cybersecurity. There are prizes out there, and again, it's just some real-world kind of challenges out there. And cybersecurity is a really big deal, has been for some time, but it's a very big deal right now. We have a Makers Club where students interested in just building things, some 3D printing, some design, and building a whole variety of systems. There are some competitions, and it's a good club to be in. The Aerial Systems Club is, of course, for aerial vehicles, and this club has been making drones for quite a few years. Before there were any commercially available drones, we were building drones here. The Oakland Robotics Association, and one of the things that we have been doing on campus here, and before anybody knew what an autonomous vehicle was, we have been hosting an autonomous vehicle competition since back in the early 1990s. I think 1991 was the first one. Nobody knew what an autonomous vehicle was, but we were hosting this international competition, and we continue to do that to this day. So student groups build a new robot every year to compete in this competition, and others out there, nationally and globally. We have won this competition twice since the early 1990s, and placed well several other times. If we look at numbers by gender, we actually have made quite a bit of progress in attracting an increased female enrollment. So our numbers have been trending upwards over the years. And if we went even further backwards in time than 2015, the numbers were even smaller for female enrollees. And now it's quite a bit higher. And the same thing with underrepresented minority students. So we're attracting a diverse group of students. We have support services to offer all of students. We have our own tutoring center. We have some mentoring programs for first generation college students and other support services to help retain students. Society of Women's Engineers is one of many organizations here on campus that females in engineering can just plug into right away and be involved and meet some other members. And there's some mentoring and there's some friend making in here. It's a good club to be a part of. It's very active here on campus. If you have any questions, here is a link to our website, and on that website you can get a hold of any of our leadership in the Dean's office. There's an email just for the Dean's office, and you can feel free to reach out to us with any questions that you might have. Thank you very much for listening to this.